Hey there, welcome to Boolean Algebra. So Boolean Algebra has the following law. Let's write down Boolean Algebra laws. Boolean Algebra laws. So you have x dot y equals y dot x. So this is all like probability. It's like regions you're multiplying. It's like so x is a set or an event. So dot means the intersection, and plus means the union. So x union y is also equal to y union x. So my camera's kind of overly saturated right now, but you should be able to see that. So then you have some laws that arise. Then you also have x plus y plus z equals x plus y plus z. So if you do it like that, it also works. Doesn't matter where the bracket is. It's all the same thing. And same for the intersection. You have x dot y dot z equals x dot y dot z. So you have these laws are all there. And a few laws that don't make as much sense would be, well, this one makes sense. You have x, y plus z equals xy plus xz, you know, it's pretty intuitive. And then you have one that's maybe a bit less intuitive. X plus yz equals x plus y x plus z. So for this one, you have x, xz, yx, and yz. But since you're, so xy, intersection of x and y, and the intersection of x and z, and the intersection of x with itself, that's going to be the totality of x, and the only remaining will be y times z, or the intersection of y and z, which is, you know, just itself, y and z. So you have, so that's why that law is like that. So you have the idempotent law, xx equals x, and x plus x equals x. So yeah. You have a probability. You have, so the probability of an event A is going to equal a number between 0 and 1. So 0, this is how probability is defined. So 0 means it'll never happen, 1 means it'll always happen, P of A is the number between 0 and 1, showing the likelihood between 0 and 1. So if it's 0.1, like a 10% chance, 0.5, 50% chance, or if it's like 0.99999, it would be like almost 1, but there's an off chance it might not occur. Then you have your entire sample space called S. But let's say here's your, this is S. This whole region here is S. So any thing that can happen must be contained in S. So the probability of S happening is always 1. And the probability of S not happening is 0. And the bar on top is like the negation. So this is S bar. S with the bar on top means not S. So that means you're drawing from this sample space. What are the odds of drawing something outside of the sample space? Well, it's 0. And the odds of drawing something inside this, it's 100%, because it has to be. Based on how it's defined, it has to be within this. And then so then you have a union. Say probability of A1 plus A2 plus A3 plus ... plus AN. So what if you have a bunch of unions, what's the probability of that? Well, it's going to equal 1 minus the product from I equals 1 to N of 1 minus P of AI. So it's kind of like 1 minus, you have the probability of all of them not happening. So 1 minus P of A is equal to the P of not A. So then you multiply all those together, and that's the probability of all of them not happening. And then 1 minus that's the probability of them actually happening. So it's kind of what you can do due to the nature of the, kind of like this law, and being between 0 and 1. And but if they're mutually exclusive, then probability of A1 plus A2 plus ... plus AN, if they're mutually exclusive, it's going to equal just simply the sum from to N from I equals 1 of probability of AI. So mutual exclusivity means that the events don't overlap. So let's say you have this is A1, this is A2. There's like a slight overlap. So they're not mutually exclusive. You can have an event take place that's in both A1 and A2. But if you have A1 and A2, you can't have anything that's at the same time A1 and A2. They're called mutually exclusive. That's when you use this equation. On to the next quality mathematics. On to the next mathematics. If you have an intersection, so the probability of A1 intersection A2 to AN is just simply equal to the product of all of them. A1 times A2 AN, because so you have A1 A2. So the probability of the sample space would be the probability of the entire S here, which would look like, you know, like this. That's like the sample space. And A1 is this whole guy, A2 is this whole guy. So the odds of them both happening at the same time would be like A1 over S times A2 over S, right? But S is equal to 1. So it's just equal to A1 times A2. This is probability of it, but yeah. So that's kind of clear. You just multiply them through, because then you're if you multiply, it's like 0.4 and 0.6. So the odds of getting that 0.4 and that 0.6 at the same time is the intersection. So that's all that is. And the probability of A happening plus not A happening is always equal to 1. So let's say probability of A1 is going to be like S is equal to 1. So probability of A1 is going to be like, let's say 0.4. So A1 not happening, therefore, is the remainder of the S, which is 0.6. So 0.4 and 0.6, you always get 1. That's all that is. Pretty easy. Okay, then you can define probability as probability of an event X is equal to the limit as n approaches infinity of capital N over lower n, where n is the number. So n occurs, n is the number of x's that show up in n experiments. So n is the number of x that shows up in n. So you do something n times, you get x capital N times. So as you eventually do infinite experiments, you'll get the true rate that n occurs relative to n happening. So n is going to be 1, because n just always occurs. You're doing like, let's say you're flipping a coin, that's n. And then x means x is heads. So let's say heads shows up 50% of the time. You know, at first you might get like 25%, like a weird number, but if you do it infinite times, it'll approach exactly 50%. Unless you count when the coin lands on its side like this. But that's, we don't talk about that. We're not going to talk about that. So that's it for today. That's Boolean Algebra Introduction. Hope you enjoyed that. Probability and Boolean Algebra. It's from this book, Design Reliability by B.S. Dillon, a very accomplished reliability engineering professor. And I'll put the link to his book below. And thanks for watching.